This experimental protocol is to visualize the detailed flow fields and the near-boundary shear and normal stresses within an equilibrium scour hole induced by a force vibrating pipeline.
The key advantage of this measurement technique is its capacity to simultaneously obtain pipeline dynamics, flow fields, and near-boundary flow stresses in high resolution.
By using this technique, more in-depth studies of the two-dimensional flow field in a complex environment can be conducted to better understand the Scour mechanism.
The experiment takes place in a flume 11 meters long. The cross-section is square, with side length of 0.6 meters. This schematic view of the flume provides additional details, including the location of an erodible seabed model. The water level is 0.4 meters above the seabed. In the seabed model, use uniformly distributed medium sand that has been compacted and leveled. Have the structure for the vibration system in place over the flume. This consists of a fixed frame that is locked on the top rails of the flume. The fixed frame has a movable pole that supports an aluminum frame. The aluminum supporting frame holds the pipeline model above the seabed model in the flume. This schematic provides an overview of the setup. Note that there are 4 bearings that ensure the aluminum supporting frame can only vibrate vertically. A connecting rod between the movable pole and a servo motor drives the motion of the aluminum frame. The setup depends on the pipe geometry.